Assalamualaikum warahmatullahi wabarakatuh. My name is Nurin Hazwani Binti Hussin. Today I will demonstrate on lab 2 question 2, which is this is the code that we get, and then we will execute one line by line by pressing F10. Okay. So first, this is the first line, and then x value is this. Okay, so we execute another to read line 1. So line 1, move x value to EAX, which is this one. So EAX become a value from x value from before, and then we execute again to line 2. Line 2, we need EAX. EAX is declared by this one, FFE6, because we negate the EAX negative by 2 complement. And then line 3, we want EBX and Y value, which is the Y value is before that we have, which is this one, 30, but we need in hexadecimal. Okay, and then we want EBX, move at Y value to EBX. So Y value from earlier, we move to EBX, which is this one. And then another line, press F10. So we have line 4. Line 4, we want EBX and Z value, which is we subtract Z value from EBX. So EBX will become -10, and then this is the value FFF6, and Y and Z value is this one, 40. And then another line, we add EBX and EAX, so we have EAX equal to this one and EBX equal to this one, and we put it on the table. And then we put another for increment EAX, we plus 1, so we have this one from C to D, and then we put on the table increment from -36 plus 1, so we get -35. And then for line 7, we move EAX to R value, so R value we got the same, which is FFFFDD. So we got this one and this one for at the memory. Okay, so now I will explain about question 4, which is this a code. We already paste it on here, and then we just tap F10 to execute. Read. Okay, line 1, we have 0028 on EAX. We move variant 1 0028 to EX, and then by line 2, we move 5 to BX, which is the EBX become this one, it move constant. And then next line, which is line 3, we have multiple AX 40 by BX, and the result is stored on EX, which is this one, 00C8, and BX is still the same. And then move to the next line, which is line 4. Line 4 is move variant 2 to BX. Variant 2 is 10 in decimal. We put it into BX in the hexadecimal, so we got 000A. And then move to the next line, line 5, which is subtract 3 from BX, so BX becomes 7, which is this one. And then line 6, we have divide BX in this code. So we divide AX by BX, so make it a quotient 28 and the remainder is 4. So AX is this one, 0001C. This is the quotient, and then the remainder is 4. This one EBX 0004. The EBX is still the same one. And then we move to the next line, which is move AX to variant 4 and move the result of in AX. And then we have AX is 001C, and then VR4 variant 4 is still same because we moved the result in EX to VR variant 4. Given the following instruction as is code snippet 2, so we need to write a full program to execute it. So this is the program, and I just add call dumbbells to show the register after execution. So first, let me execute it. Okay. On the first line, we have move 0 to the X, so we clear it. So we have 0, 0, 0, 0 in here. And then the next line is move 803 to EX. So we have this one 0803. And then we have move 10 to BL. So to BX we have 0 to 0, 1, 0. And then we divide the BL. So when we divide, we have DX and the AX, whereby AX is the quotient and DX is the remainder. So the quotient in AX is this one 0380, and the remainder is on DX, which is this one 000. And then we need to call the dumb register for execute all of it. So this is the all register that we show on final content, which is this one. Thank you.